Okay, I finally got around to trying to put together a little short video to illustrate what the 5.56 by 24 is as opposed to the 22 TCM and the 22 TCM 9R. So we all know it began with this little cartridge, the 22 TCM 9R, or the 22 TCM. This fits in a 1911 size pistol. Unfortunately, it can't cycle through a 9mm size pistol, which leaves out a huge part of the market. So Arms Corps eventually came up with this, the 22 TCM 9R. And as you can see, it's a little bit shorter. Now, that solved the problem of cycling in 9mm. It uses a 39 grain bullet with a little round nose jacketed hollow point. It's actually a very efficient bullet, very effective. Probably would outpenetrate the more exposed lead TCM 40 grain bullet. However, when this round was introduced, Arms Corps didn't see fit to put this bullet on the market for hand loaders and reloaders. Naturally, for those of us who live in ammunition restricted states, that poses a problem because we can't just order ammo to our house as people in other states can do, and as we used to be able to do. So when I first got into the TCM, I basically had to put together my own because you can't buy a TCM in California. So there I was. My first thing was to try to cut the nose off of bullets. Obviously, makes sense, just shave this lead off and it should work, right? The problem is that you see how this bullet is rounded? That's important to understand because once it's in the magazine, if you don't have that rounded shape, they're easy to bind. If you just cut the lead off of this bullet and put it in a magazine, it's going to bind up in the magazine unless it's either seated more deeply or you take the time and effort to try to round the nose. As you can already tell, this is tremendously labor intensive for what should be a relatively easy job. Clearly the right answer isn't trying to reshape bullets. So while contemplating that I had basically just bought a gun that I would probably never be able to shoot until I figured out a way to go order a large supply of ammo, it hit me that the right answer is to change the shape of the case, if possible, to work in the standard TCM barrel. So towards that end, I did a little research and discovered that the 223 Remington Improved, that's an Ackley Improved chamber, has that sharper 40-degree shoulder. It's basically the same as the upper portion of a TCM case, except it has the sharper shoulder. So I got the Elite 223 Remington Improved die. I think it cost $20 for the sizing die. And I cut off the bottom of it. So as you can see here, it is mostly no die. Now, in order to fit in the frame of a press, I had to remove the lock ring, and I had to actually grind away a significant portion of the upper part of the die so that it could screw down far enough into the press. At the same time, I removed the decapping stem and rounded this, but what you can't really see is whereas the upper side is also rounded, I gave it a much longer taper. The idea there is that when you reshape your cases, it doesn't pull the neck back out, which is quite easy to happen. The edge of this is actually beveled and polished. As you can maybe able to see, this is also polished. The actual outside portion doesn't have to be done perfectly. It can be fairly rough because it has nothing to do with the final product. But inside, the shoulder is about 1/4 of an inch further from the entry point. This is actually the form die for the 5.56 by 2.4. That's all it is. It's nothing more exotic. So when you use this die, you first use a standard 22 TCM size die with the standard decapper. You set it for the standard resizing depth. This die is adjusted downward until it sets back the neck of the shoulder but leaves the edge of the shoulder in its original position. And here's what we're talking about. This is the 5.56 by 2.4. You see the angle is much sharper. It almost looks like the little brother of the 22 TCM. The case shoulder has been steepened to about 40 degrees, and the neck has been trimmed, and this results in about a 2 millimeter reduction in case length, hence the 24 on the end of the name. What this does is, as you can see in the picture, is it allows you to use the standard Armscore 40 grain jacketed hollow point, which is widely available and inexpensive. It can seat normally, but it's short enough to fit in a 9 millimeter length action. And here is a nickel-plated 22 TCM case with a Armscore 39 grain bullet, and you can see that they're basically the same length. So both of these will fit into a 9 millimeter magazine. They'll feed from a 9 millimeter magazine, and they both headspace properly in a 22 TCM chamber. Now this is a 22 TCM 9R barrel. Now, and here again, just because it says 9R doesn't mean the chamber's different. The 9R and the TCM have exactly the same case. The case is identical. It's identical. The difference is one uses the short stubby 39 grain bullet, the other uses the 40 grain bullet. The reason they put this on the barrel is so that you know you have to have this ammo for it to cycle through your gun. This ammo you could actually load individually. You can actually put one in the magazine, chamber it from a 9 millimeter, and shoot it. And the case will eject normally because once the bullet's gone, the cases are the same length. But this barrel, which is designed to hold the 22 TCM case, you can see drops right in. Doesn't matter that this is a original 22 TCM. The 22 TCM 9R drops right in. They're identical, as I've said. And here's the 5.56 by 2.4, and it drops right in. So the head spacing is correct. When it fires, what happens is the shoulder basically, it doesn't so much blow forward as it reshapes to this shape. That's all that happens. So surprisingly, the stress on the case is not as extreme as you might think. I think a lot of people think the case would fail. I have cases that have been reloaded upwards of 5-6 times. Some of them I think I've lost count. Unless you're going for maximum loads, and even then, because the case walls are so thick. If you look at the specification for the TCM, it actually has a very thick brass case, even at the neck. You'll see a lot on the internet about forming cases from 223 down to 22 TCM, and people get all involved with discussing neck turning and correct tensions and all this nonsense. The fact of the matter is, the case was designed to be formed. If formed correctly, there's no need for neck turning, not at all. The problem is most people forming cases are trying to do the one-stroke method. Essentially, heat the case up and anneal it, or do what they think is annealing, and to soften the upper aspect of the brass, and then slam it into a press, and out comes your brand new 22 TCM case. And that does work, but one of the problems with annealing brass is it's not quite as much of an imprecise process as is portrayed in a lot of these videos where they're just using the torch method. It can be done, but I assure you, no manufacturer anneals that way. So the right answer, if you were going to form any of these cases, and I have formed these cases from 223 rifle brass, the right answer is to do it in stages, and that I'll get into that in another video. But essentially, I use 3 to 4 different larger dies, all cut down appropriately, to stage the case forming operation so that the final result comes out with a perfect neck diameter or perfect neck wall thickness, no need to anneal, and the brass is very strong. But that'll be for a future video. So as you can see, the 5.56 drops right into that case, or to that barrel chamber, just as the 22 TCM. Alright, so the next thing that you have to do, and this is really necessary not just for loading the 5.56 by 2.4, but for any 22 CCM loading. And the reason is because when Lee came out with these dies, they made the seating stem so that it barely protrudes through the interior of the die body in order to contact the nose of the bullet. So essentially you can, and also with the original adjusting cap, you can only screw it down so far, and essentially the stem would not go far enough into the die to seat the 22 TCM bullet. Clearly that's not an acceptable solution. So the first thing I did was use a spacer, which just happens to be a Barry's 124 grain plated 9mm bullet, and that spacer fits on top of this seating stem so that when you screw it down in the die, you actually can bring this stem as far down as possible. Well, that made it possible to seat the shorter bullet, but the next problem is that the 22 TCM has a very large body diameter compared to its neck. What this means is that when you situate the bullet here and you introduce it into the die, there's a fairly wide mouth here that the bullet can tip sideways as it travels inside, which of course it often will, because when it comes to reloading, if something can go wrong, it's absolutely going to go wrong. So there had to be a better solution. And it doesn't always have to be a high dollar solution, and in this case it's not. Originally this seating stem had about this much of the tip was this diameter, the rest was this diameter. What I did is I simply took my handy Dremel and turned this in my hand while I dremeled it down. You could chuck it in a drill, and if you want to get fancy, you could crack open the lathe and do it that way if you want it to look really, really factory. But since this was a prototype, there's not much point in trying to make it look fancy. So basically, I ground away all of this diameter back to about half the length of the seating stem. This allows the seating stem, instead of only going this far inside the die, basically, to go all the way down here. And you're wondering, well, what's the advantage of that? Well, the advantage is that with the seeding stem all the way down in the die, you see it sticking out, and it will angle off like that because there's nothing holding it vertical. But when it's in the press, it is in the vertical alignment. So as you introduce the bullet, when you're seeding cartridges, here, let's use this one. You position the bullet on the case, and then you hold it with your fingers as you align the nose into the seeding stem, the little socket, just like that. The weight of the seeding stem will actually hold this in alignment as it passes into the die for seeding. With this modification, I've had no more crushed or deformed bullets, no case necks twisted out of shape or any of that kind of stuff. So this is a modification. It would be nice if Lee actually incorporated it into their regular dies. But for the 22 TCM, or in this case the 5.56 by 2.4, this makes it very easy to load the shorter cases, to get the correct seeding depth, and to do so with perfectly aligned bullets every time. So essentially this drops in, insert the spacer into the cap is probably the best way, and then hold the two level and get it started, and then you can screw this down to the press. And this does have an internal crimping point, which I don't advise trying to crimp this. You can round the edge a little bit, but what will happen is you'll collapse the neck. You'll collapse the shoulder, I should say. It will buckle, and you end up with essentially an unusable round. So with this in place, if I screw this all the way down just so that you can see, and you could seed it you could use it this way if you wanted. This makes the stem, it's still going to retract up in there some amount, but as you can see, I'm going to use this longer case. It's easier to show this. You can see the nose goes in like that. As the whole thing goes up, you reach the point where it can't go anymore, and it pushes the bullet in. Boop, boop, just like that. Very simple. So that is basically what it takes to create the 5.56 by 2.4. Now you may be wondering, why would one care? Well, mainly because the 22 TCM9R only uses this bullet, unless you want to get into custom fabricating of bullets. What the 5.56 by 2.4 does is it uses any bullet this can use, as you can see here. It can use the Spear 40 grain Spire point, the 33 grain jacketed olive point, or even Spear's 46 grain flat nose jacketed soft point. So that gives you a lot more versatility with this cartridge than with this cartridge. In terms of case capacity, because of how deeply the bullet seats into the case, even in this configuration, capacity is not that greatly reduced, or I should say usable capacity, because all of this neck length and this little bit up under the shoulder here, that's generally not usable space. So all we're essentially doing is bringing the neck and shoulder back to a more practical location. This case will easily hold 11 grains of pretty much any powder. It'll actually hold probably, if you pushed it, 12 grains. I've found that using Ramshot Enforcer, which is an excellent powder for the 5.56 by 2.4 or the 22 TCM, about 11 grains is a good, it's a sturdy top load. Even out of a 4.5 inch barrel Glock, it will still exceed 2,000 feet per second. I'm certain it's over the book value. Accurate Arms makes TCM powder, which is slightly slower burning than number 9. Now the TCM and the 5.56x24, they need the slower powder to cycle because, remember, this round is designed to work in existing pistols with heavy slides, heavier locking systems. So unlike the 5.7x28, which was purpose built to operate in a blowback system, and then the 5.7 pistol was designed and adapted to work with the cartridge. So the 5.7 pistol has a very light slide, a very quick unlocking cam locking system that works in line. So the 5.7 is an example where the gun that shoots it came after the cartridge. In the case of the 22 TCM and the 9R and the 5.56x24, we're basically working with modified or adapted pistols. So a 1911 has a fairly heavy slide, as does a Glock. So to get all that weight moving in the right direction, you need a solid breech thrust. And one of the ways you do that is by going with a slightly slower powder. You extend the time pressure curve. So instead of getting this quick peak that begins to descend, it delivers a very short high energy impulse. You extend the impulse for a longer duration, and this of course is what is required to get that slide to go all the way back. The original designer apparently used H110 and Winchester 296. Those are much slower burning powders. I've actually tried it. Now from the 5-inch 1911 barrel, it's adequate. From a 4.5-inch barrel, it's way too slow. And this is why you get that big fireball that everybody's so enamored of. The fireball is essentially telling you have a cartridge that isn't efficient. You're blowing powder out of the barrel, or you have incomplete combustion, as they like to say. So the right answer is something a little quicker, and that something is Enforcer, which is about 2 steps slower than Accurate Arms TCM powder. There's no doubt that you could probably get some credible results with Accurate number 9. Also using crimp. You don't hear much about crimp with the 22 TCM, and you really don't need a crimp as long as you stay with those slower powders. But with the judicious use of a crimp, and you can see, you probably can't see it, but this round is crimped, you can delay the bullet leaving the case just that tiny instant, allows pressure to build to a sharper peak, and could in fact make a faster burning powder have the energy necessary to cycle the action. But that's all part of researching this stuff. But basically, with powders between the burn rate of TCM, Enforcer, Little Gun is a good powder. It's a little coarse for feeding through a powder measure for really precision throws. And that brings up another point. The Accurate Arms powders, as well as Ramshot powders, at least the Enforcer, are a tiny spherical, which means they flow very well through a powder measure. I have a Redding 10X. These things drop, I mean, almost to the exact. It's impossible to tell to the 10th of a grain. And I use an actual balance scale instead of an electronic scale, and that's also a video for another time to explain why that's what is actually a superior way to do it. So that pretty much sums it up for this video.